All right, everybody come on, sit down because the special treat of the evening. We have Michael Coates all the way from San Francisco. San Francisco now? As I mentioned already, Michael used to be on the board. We checked this out, by the way. We were both right. Started 15 years ago, finished 8 years ago. Yes. Yeah, we had to change the rules to not to stay on the board too long. Without any further ado, I'm going to pass it over to Michael, please.
Great. Thanks so much. I really appreciate the invitation. Thank you all for being here, allowing me to be one of the speakers tonight. I hope to share some perspective, how I've seen some interesting things in the world, some interesting challenges I've gone through, and how that relates to this interesting topic of what do we do with security when the challenge is that everyone and everything can develop code. And I think that's a really interesting shift in where we've been and where we're going. We've had a whole bunch of security primitives before, an entire system of governance, guidelines, guardrails, processes, technology, and they're kind of all blowing up in our face right as we speak here. Before I get into it, I'm very curious, who in the room here is focused almost entirely on application security? All right, and then does anyone here have broader governance to run the entire security program outside of AppSec, maybe infrastructure, operating systems, endpoint, things like that? Okay. What about governance oriented? Is anyone like GRC focused? No? Okay, 0. Oh, no, there we go. There's one. Yep. Okay, very good. Very good. And then how many people have shipped code to production before? That's great, actually. That's a lot more than I thought. That's really exciting. For those of you that are just online, most everyone is an AppSec, and a good percentage of people have shipped code to production, which is awesome. The more people that touch code, the better we can be at securing it all. So a little bit about, nope, click, maybe not. Let's see here. Clear, we're in annotation mode. There we go. So a bit of a preview of where this is going. When we talk about AI and code creation, this is going to be a talk about asymmetry. It's going to be a talk about how asymmetry is beneficial to us and how it is incredibly challenging. And I'm curious, does anyone know what this statue is of? Yep, David versus Goliath. So a bit of asymmetry there as well. And in the end, the smaller guy won, and so hopefully we will prevail as well. Now, on the screen here, you see some photos of an application, a mobile application. Hopefully it looks nice to you, well designed. Believe me, it functions well. This app is a macronutrient analysis app. A friend of mine built an entire company on this model where you could submit photos of your food. Dietitians would review those photos. They would pull together nutrition information. They would talk to you. It was a venture-backed company. It went for many years. He had many employees, many developers. Ultimately, he was acquired by One Medical. He went on to be their CTO. It was a great, very successful company. This is not that app. This app is an application that I made in 30 minutes sitting in my car on my mobile phone while waiting for my daughter to finish swimming. I recreated his entire venture-backed business in 30 minutes on my mobile phone. That is where we are today with the power of AI coding, in this case, vibe coding. It wasn't anything that clever. It wasn't Claude code, purely from the web interface on the mobile device. So it's pretty amazing what you can create without too much effort. Now, since I've never given this presentation before, one thing I've realized is I've given away the next item, which is it only took 30 minutes, but there it is again. 30 minutes to create that, and all from my mobile device. For those of you that are interested, I used Replit to build that software. Replit, Lovable, they're all great. But it is incredible what you can do. Now, taking that story one step further, I was talking to a friend of mine in Las Vegas, and he was a business major, or was a business major. but very interested in innovation technology. Showed him the same thing, showed him what was possible with Replit, and off he went to build applications. So here we have another situation where someone who has an appreciation for technology is now shipping code and creating apps. His wife does not like me much right now because for the rest of their trip, he was walking around shipping features to his new application. So as was covered before, the rise of AI-assisted code creation is growing incredibly quickly. These stats showing that as much as 30% of Microsoft written by AI, over 25% of Google written by AI. These are actually old. This is almost a year or 6 months ago in some case, and one of those is a year ago. So we can only imagine how fast things are increasing. So no question that AI is going to have a huge role in all code that's being created. Good, there we go. 1 second. I've lost the window. Sorry, bear with me. There we are. Okay. But how secure or vulnerable is AI generated code? So one great resource that I will point you at, if you haven't seen already, is Backbench. Has anyone seen that before? No. One hand, great. So Backbench is actually analyzing LLMs and how the code created from them and whether or not it's secure or not. Now, these are just a few high-level takeaways, which I think are going to be really hard to read from there. But they have breakouts by LLM showing which model generates what percentage of code secure versus insecure. And they have a series of different tests and an entire white paper that goes through how they do that. But the takeaway from this, and the other stat is from Veracode, I believe, their Gen AI code security report, is that 45% of AI generated code had flaws. So about half the time there are security vulnerabilities in this code that's created. So as we create code faster, we're also creating vulnerabilities quicker because about half the time there's vulnerabilities in that code itself. So we have this interesting problem on our hand of everything is changing in front of us. Everyone is coding, everyone is shipping faster, but it's incredibly vulnerable at the same time. So what do we do about that? So one thing I'll say from this is looking back at where I've been, change in how you do things in and of itself is not bad. It is scary, but we can figure it out. We can get through it. And so I think back to where I've been, and I've had an interesting time in Silicon Valley. I moved out to San Francisco 15 years ago, and I joined Mozilla. Who used Firefox? Great. Who still uses Firefox? Oh, great. I don't really. But Firefox is great. I love the mission. Ensure the internet is open, public resource, accessible to all. It's a very interesting company. It is a for-profit entity that is solely owned by a nonprofit organization. It is. It was up to 1,000, 1,200 employees at one point in time, but also an entire an entire open source contribution-based organization for code submission. So as I walk into this company and I'm helping secure and run the security organization, we think about how can we do security? How can we put controls? Like, let's make sure our workstations aren't compromised so that nobody could submit code maliciously. Like, well, half of the code comes from people that aren't employed, and we have no control of their workstations. So it was BYOD before BYOD was a thing. We had the mobile browser we were building. We had Firefox OS, the mobile operating system we were building, and of course, Firefox, the browser with hundreds of millions of users on it. And we had very interesting challenges and decisions to make, such as when there was a CA root hack of DigiNotar, I believe, many years ago. And we were looking at that and whether or not to remove them from the root store, which would essentially put them out of business. In that case, if you remember what happened, we did. We removed them from the root store. That company ceased to exist because a third of the market no longer trusted them. But we had these very interesting challenges of what to do to think about security and how to think about this changing landscape of the risk profile. So This wasn't the first time that I'd seen non-standard deployments and non-standard realities. Now, Twitter was another interesting place that I was at after that. So interestingly enough, I joined Twitter in 2015, I believe, or 2014. And they were a public company already at the time. So they had 5,000 employees at this point, hundreds of millions of users around the world, and they had never had a chief security officer. They had a security team. They had someone who was the head of the team, but they went public without even having, that role filled, which wasn't too abnormal at the time, but feels weird in retrospect. At Twitter, this was, again, 2014, this was Trump's first presidency when he used Twitter as his constant talking point. And you remember some of the interesting things that happened there. In the first 6 months of my time at Twitter, we had a nation state attack. We had the FBI come to our door and said, you have an insider selling secrets to a foreign nation. And then they said, good luck. We're like, oh, can you tell us who it is? No. Okay. So we then went on this expedition this was 6 months into my role when I knew all the things that weren't working correctly and trying to figure out, all right, who is it? What data do we have access to? What would they possibly be stealing? What things do we have logging for? How do we parse it? We had the best pivot tables and spreadsheets in Excel you can imagine at the time. And we went through it and we figured it out. You can read about the outcome because that person, one of the two people, was arrested and convicted a few years ago. So it was very interesting challenges. And then all of this is on the same topic that this is one of the largest distributed graphs in the world in terms of technology, with billions of timelines, views, and a focus on real-time systems. So everything we built for security had to be nearly instant, or it didn't really matter. Now, back to the threats that we faced there. I mentioned the nation-state adversary that we faced. We had cyber criminal threats. So we had the Our Mine hacking group, if anyone remembers this group. They would go after high-profile accounts and compromise those Twitter pages or those Twitter accounts, often through interesting edge cases. Very rarely was it just a weak password that they stole. Sometimes maybe it was phishing. But they would do clever things like compromise a third-party system, like your Yelp account, and then find that you had tied that trust to your Twitter account. I don't know who needs to tweet automatically when they do a Yelp review. But nonetheless, some people had this set up. And that's actually how they compromised Jack Dorsey's account at one point. Another interesting threat that we had to face, as it says there, is foreign tax raids. So if you are doing business around the world on a platform that is designed to enable free speech, you have some countries that do not agree with the existence of that speech. In those situations, they would pressure us in different ways. One of those ways would be to raid the office for tax purposes. And they were looking to gather information, gather data. And so we had to design the security controls that would protect our data, but would also not indict or not implicate our employees in those offices, because if they knowingly cut access to the data, they were impeding an investigation and they would be arrested. So we had to protect our employees from being arrested while protecting the rest of the world's user data. And then all of this was going on where we had the fail whale and interesting uses of the platform. Does anyone remember that photo? The bottom right? So that photo is a selfie that was taken at the Grammys or Oscars in the United States in 2012, maybe 2013. And it brought down all of Twitter. It was the most retweeted tweet, and it overloaded the systems in ways that we weren't prepared for, and then down went the system. So all of these interesting things. And the reason I bring all this up is everything is always changing. The landscape that we are thinking about protecting is changing from under us at all times. And part of the excitement of this job is being flexible and adjusting to these interesting situations. So back to asymmetry. How do we think about doing security when you have all of these interesting things at play, when you have these employees, these volunteers, these people you can't control, when the time that you need to respond to something is in sub-seconds? And so it's about asymmetry and leveraging the few number of people you have in your security team to do things in clever ways. So one thing that was very successful at Mozilla was going straight to the framework for web vulnerabilities. We went straight to the framework and found how to harden the framework against things like cross-site scripting attacks, the secure flag, obvious things like that. But setting at the framework level and then giving people a secure framework out of the box, it seems obvious in retrospect, but made a world of a difference when you're thinking about the scale we were dealing with. Does anyone have oversight for bug bounty programs? Yep. Were you there when you launched the program? What was that? Inherited it. So one fun thing about launching a bug program is to not do it on a Friday or at the end of the day. We launched the web bounty program for Mozilla, which I believe was the first web bounty program. At that time, there were a few bug bounty programs, so this is the first web application bounty program. And the thing you don't really expect is you get tons and tons of reports, of which much of it is garbage. And this was far before HackerOne existed. And going through that overload of inbound reports, it really shocked the engineering team, to be sure. But now, as we've kind of figured out how to do those well, that's another way of using asymmetry for your advantage. The fact of the matter is we had great security steps and guidance and controls at both Mozilla and Twitter, but we still got really interesting bug bounty reports because the hackers would spend the time to figure out the very clever different iterations of something that could lead to a flaw. Something that when we see, we're like, well, wow, that's really clever what you figured out. We would never have thought to see that issue ourselves. And then the other piece that I'll point out here is around ownership. One thing that was very successful in scaling the security was thinking about making security be additive, but the engineering teams own the vulnerabilities and the risks themselves. So don't shoulder this all yourself, but rather make the teams own it. Now, one thing that I've realized works very well is thinking about what actually moves the needle for security. And so on one hand, we want to put into place security policies because it feels like the status quo. It feels like what you're supposed to do. But I would say that policy and awareness is really the weakest control of how you're going to help things. The goal is to move left, shift left whenever we can, and transparently secure things and take the problem off the table. So as you can see here on the far right, policy and awareness, the stage 3 there, observe and report. We're going to just test it and report back when there's problems. This has tons of challenges with scaling. The golden path is good. This will be secure if you do it this way. We're giving them libraries. We're giving them frameworks to build things securely. Netflix is very big on this golden path approach. And then transparently secure it. So take the problem off the table. Now, one example of this at Twitter, we were dealing with service-to-service authentication, or the lack thereof. How do services within the data centers talk to each other? And we could tell people, hey, the policy is you have to authenticate your services. Would anyone do that? Probably not. We could observe and report, which would be us just telling everyone, you're missing the boat, you're not securing, you're not doing authentication. The golden path approach could work, like here's the way to do it, please do it. But what we did instead is we built the service-to-service authentication layer and then we deployed it across the different services. But I think that while this seems far removed from the technical details, this is really important as you think about what scales for security. And this is especially important as we think about how things shift with the rise of AI-generated code. All right, so quickly how development is changing. All right, so on the notion of asymmetry, control versus speed, we've already been through a shift before. If we lived in the world of waterfall before, we had all of this control. Things move very slow. All right, we're going to do our requirements. We're going to do our testing. We're going to do our deployment, staging, prod, et cetera, et cetera. And then we shifted to agile. Who can ship code any time of the day, every day at your company? Oh, wow, that's only a few. So are the rest of you mostly waterfall slow contained windows? Sorry, was that a yes? Specific time windows. Okay. So one of the things that I ran into very quickly in Silicon Valley style companies is it's just whenever you want all the time, keep shipping, keep shipping. And so you fail fast, but you don't have that control. And so we've been through these transitions before, and this transition to AI code is not going to be any different. So in terms of how things are changing, we've got AI code generation that's AI assisted. We've got AI doing large refactoring of code. And we've also got this element of offloading logic to LLMs that I'm going to come back to in just a minute. So we've been talking about engineer-driven code. The other side of the coin here is non-engineer shipping code. And isn't wild that we now have to deal with this reality of what if finance comes to you and says, hey, can I get some credentials to the database because I need to connect the app that we just built? The finance team will do that. The HR team will do that. Your salespeople will do that because they can now vibe code up an app, and that app is very compelling and it's helping them move fast. And all they need to do is get real data into it. And so we're at this interesting situation of, do we take all of our secure SDLC that we've designed and then run finance through it? I think the answer there is definitely no, but what do we do and how do we trust that? How do we trust that it's going to be secure? All right, so fundamentally, we have a few problems in front of us. We've got the challenge of managing the increase in scale and volume. Everything we did before, if we keep doing it, is going to fall apart, is going to be overwhelmed. Your static analysis is going to generate some amount of false positives, some amount of true positives. But if code increases 10x, that method isn't going to work. We're going to have to shift into the IDE to have any sort of chance. We've lost control. The code is going to grow and bloat. It's going to be harder to understand. And I fear the moment when the developers no longer understand how the code works because they have had so much of it created by AI itself. So this is a pending challenge that we're going to run into. And the other challenge is about operating to standard. The benchmark that we're talking about secure AI code, if we get to a point when it is generating secure code, secure according to who and what? And I think the challenge here is whether or not we use standard libraries, standard organizational approaches, like what is your method for using logging, authentication, input validation, access control. So I think there's going to be a huge shift into defining the standard of what the enterprise wants to do for security in code itself. So in terms of how I think we can help and what we can do, if we want code to be generated correctly and securely for our organization, I think the big advantage that we have is pushing greater amounts of information into the code generation pipeline. So what I view as the future of what's coming is that threat modeling, requirements gathering, that will be nice and codified and pushed into the model so that it understands the business context of what's being created. That way AI can actually code things that make sense for the use case, not just generically secure, but secure with the business context in mind. The other thing that I think is coming is that the only way to do fast code creation is to be able to automatically fix bugs. Now, what happens if you just start fixing bugs automatically? What's the unintended byproduct of that? Additional bugs, yes, because of breakage. And the solution to that is automatic test creation. So I actually think the linchpin to making code creation better and faster is automatic test creation so you don't have unintended breakage. And then the third part of this is anyone familiar with the OWASP ASAPI project? It's kind of older at this point, but there we go. There's a few people that have been around for a while. So the ASAPI project was Enterprise Security API. And it was a way of saying, don't reinvent the wheel on security teams, use this. And it was kind of a philosophy of just defining the way you do security in your code base. I think this will come to exist inside of AI chatbot, AI code creation tools. Us codifying, this is how we do security, and putting it in there so the Claude code, et cetera, is generating it to your standard at your enterprise, not just an arbitrarily, hopefully secure way. And then we have to deal with this for the non-developers that are shipping apps, not code, and thinking about what is the security protocols that we have, because it's not the standard SDLC. We're not taking all of our finance teams through secure developer training. But what do we do to solve that? Do we have some sort of tool or solution we can plug in? Do we have some sort of way of putting a box around what it can do? I will say that as you're leading security programs, if you try and get in front of this train and say, this isn't secure, we're not going to do it, that's a hard train to get in front of. If that train is all of AI, we're just not going to do AI. Like, that's not going to work well. So it really is about us being creative and saying, what can we figure out that will do this in a reasonably safe way? So as we look at this, when Excel macros became a thing, actually that's probably older than everyone here, but we didn't say no. We didn't say, oh, you can't do that. That could be insecure. When SaaS automation came out, when you could use Confluence and Notion and Google Apps Scripts, sure, there are ways this could go sideways, but we didn't get in front of that and say, we're not going to use Google Workspace because of this. I think as we try and draw parallels, some of the control we're losing with vibe-coded apps is similar to the control we lost when we went to Google Workspace, Microsoft 365, which was every employee can now share a document in whatever way they want. How are we going to handle that? Are we going to just say, hey, don't share this to your personal account? That's the policy. That doesn't work well. And we thought about clever ways. Some of that was controls, guardrails, limitations, test and report. And creating vibe-coded apps is somewhat similar to when marketing says, well, we're not going to talk to engineering. We're going to go hire this third-party firm, and they just built the app. Off it goes. So we've been in these situations before, and the reason I bring this up is, as the problem is in front of us, all help is not lost. We're not doomed. We've thought about this before, and we can figure out ways that work. And looking back at this model again, think about ways that work, hopefully, as transparently as possible. Anytime we can take a security issue and say, that was a problem, but you don't have to worry about it because we solved it, that's the best case. Now, I say that a little bit naively because I know that's really hard. But I say it from having been, a CISO and saying you can get there, and also from my venture hat saying you should probably start a business in that space. All right, so one last thing to mention. There is this elephant in the room that I don't think people are talking about enough. And it is the role fundamentally that LLMs play. So the power that an LLM brings to us is that it can be used to offload analysis, judgment, decision-making. And that makes apps really powerful, and you can do really great things with it. But when you're offloading this decision-making to this LLM, it's non-deterministic. It's not even very transparent. So you've offloaded it, and what are the guiding lights and rules that it uses to make those decisions? We could test it. We could test it in different scenarios and say, well, when we ask for what you should do when it rains, it says put up an umbrella. So it tends to generally perform things right. But that only gives us a limited amount of exposure on how it's thinking. We could look at the weights, but that can only tell us so much. We could look at the training data. But the thing, oh boy, there we go. The thing is that the bias that's embedded in these models sometimes only comes out in really scary situations. And so there's more and more research that's now showing that this bias is real. And so specifically on DeepSeek as the first example, CrowdStrike has shown that DeepSeek itself will generate more vulnerable code when the prompts to create code are in English. Also, if you try and generate code when you, regardless of what English you prompted in, but the topic in the code creation somehow talks about Tibet, the code is also more vulnerable. Now, those of you that are, any amount aware about the world know those are sensitive topics to China. The question that might come to your mind is, oh, is that purposeful? Are they purposely trying to create DeepSeek that is vulnerable so they can hamstring something about these entities? Or is it unintentional? It's a byproduct of the training data that happened to be accessible to the Chinese developers when they created it. Either way, the bias is there. So we have this threat of intentional or unintentional bias inside LLMs. Now, I think what's coming is an actual national security imperative on this topic, where nations will say that if LLMs are being used in applications, and if those applications touch critical infrastructure, maybe financial systems, maybe health systems, that the provenance, the creation, the owners of that LLM will be judged, and only certain LLMs will be possible. I think we're going to very quickly enter a period of time where you don't select just the best performing engine, but rather you're limited by who created it. Is that right or wrong? I don't know, but I think that's where we're going to be. And I am particularly shocked that DeepSeek was received as well as it was for that consideration. But I mean, that's our job, right? We're the security person in the room, the one that's always suspicious of everything. So I think this is a topic that is getting more focus from researchers, but is not getting enough discussion because of the risk that it plays. And I think things are going to change very, very quickly on this. And so what I will leave us with here is a nice video of how I get to every meeting in San Francisco. We have Waymos everywhere, self-driving cars for taxis. I think there's a statistic that says something like 60% of Americans don't believe self-driving cars exist. And, here we are taking them around everywhere. But the reason I mention this is our role in security is not to block things that are vulnerable and say, you can't do this, this is vulnerable, this is a bad idea. Our role in security is to be clever and be problem solvers and be enablers. Because fundamentally what we do is security unlocks innovation. It enables these things. It enables cars to go fast because the brakes save us from dying. It enables rockets to go into space. It will enable brain chips connected to computers that don't kill us all. And so when we think about AI code generation, I know I didn't give you any strict answers, but hopefully a way to think about the problem. Our goal is to figure it out. Our goal is to help our businesses succeed. You've heard the old story of the most secure server is locked at the bottom of the ocean. It doesn't work. And so if we stifle our businesses to not use AI, our competitors will eat us alive or our bosses will fire us. But innovation is possible because we make it so because of security. So we're not just about preventing being hacked. We're about enabling all the great things that come in front of us. All right. There we go. Hopefully it generated some interesting thoughts. Hopefully there's some questions that come to mind. But we do have a few minutes if anyone has any questions or comments. And if you like scanning random QR codes, please do. And I believe that is my LinkedIn if you want to connect. Oh, if you do connect, please add a note. I get a lot of spam. Cool. Thanks.
I think there's a recent paper saying that LLMs are actually injective and inversible. Do you know about it? There's a new paper from 2 weeks ago or so saying that, proving that LLMs are injective and inversible. So you can, if you have access to the model, you can actually get backwards and find the prompt.
Oh, we'll find the prompt. Well,
that's a big problem. It has advantages as well, but from security perspective, that's a problem.
Yeah. So the thing, I have not read the paper, so I don't know anything insightful about it. But what comes to mind there is, on one hand, we want to have some amount of determinism on how does the system behave, so we can trust that because it behaved this way the first time, it will continue to behave that way. So in that regard, I kind of get excited. But on the flip side, if you can pull out prompts, then you're going to be able to pull out secrets, either actual secret values or secrets in the topic of which is going to be terrifying. So I don't know about the paper, but I'm going to find it and read it. Yes, thank you.
How likely do you think it's going to be that the model developers and the ecosystems where specifically for say code generation, so you look at like Anthropic, we look at Cursor, we look at Copilot. How likely is it that those ecosystems are going to build security protections and generating secure code into their models and into their mechanisms compared to having to find an alternative way or a sort of an out-of-band way of handling that?
Yeah, I think that's a good question. So I think they will definitely build it in as a add-on pricing thing. Even right now, Replit has this that has a button that says scan security. I don't actually know what it does. And I think they will do that while the code creation levels of security increases. But even after that is done, I don't think we'll be able to call it a day and say AI code generation is good. And the reason is that can only be as smart as generic security vulnerabilities. So, all right, we don't have cross-site scripting. That is great. I would love for that to be the case. But business level flaws, access control issues, when do you have authentication versus not? In what method do you do logging? I think that all gets back to the need for this AI ASAPI. How do we do security in our organization so you do things in the right case? And then the second piece is the business requirements and threat modeling. When you put those into it, I think there could be a future where, oh, it knows, okay, yeah, we do need to put in authentication on this page because of whatever the requirement says, and it can all map together. So part of that can be solved by the platforms, and then the other part is still missing, and we need additional tools for. Any other questions? Awesome. All right. Thank you so much. I really enjoyed it.
Thank you very, very much, Michael. Really appreciate you coming here, being a guest speaker for us tonight. And thank you to our speakers from Orca, Roy, and Sheer, and also thank you to Avi for his quick lightning talk, hopefully energizing you to all to get more involved in OWASP. Like I said at the start, keep an eye on our Meetup page, keep an eye out for emails. We'll announce upcoming meetups. We'll provide more information about the upcoming AppSec IL conference. But thanks for being here tonight. Thanks very much to Orca, and especially Guy from Orca, who did a lot of coordination with us beforehand. And yeah, have a great evening. Thanks so much. See you soon.